Hey guys, so today we're going to continue our discussion on related rates. Yesterday I had you guys read an article on Khan Academy kind of breaking down what related rates are based off certain problems and kind of talk about the setup of the equation because that's something that's really the sticking point for people when it comes to these kinds of problems. So I figured it's just best to kind of have you guys try that out, get some practice before we talk about doing the whole shebang, so to speak. So I would like to back up just a little bit and talk about what does finding the derivative mean. So typically, I've asked you to take the derivative with respect to x, so it's like you end up with a dy dx when you do your derivative. So what that means is this. It means that this is a value. It is a specific value that we're going to use that talks about the change in y depending on the change in x. So if I know how the x value changes, then I can use my dy dx to figure out how the y value would change, right? And the reason why we normally use d dx, finding a change in a variable with respect to x, is because the x represents our independent variable. It tells us how things change based off of this, right? And these upcoming problems, I'm going to show you how are these problems going to be just a little different from that, okay? Because the important part is understanding the context for related rates. So what do these problems look like? So in these problems, our independent variable, like a good chunk of the time, ends up being time. So we find our derivative with respect to t. So we take the derivative d dt. Right? And from there, we just have to remember our rules from implicit differentiation. So when I find the derivative of y, well, it's just y to the first. So using the power rule, I know that I should get a 1. But since I'm taking the derivative with respect to t, I don't get just 1. I get dy dt as well. Because, again, it's with respect to what variable I chose to get the derivative to. Right? So now when I look at the other side, I need to look at the x squared. So that's going to equal the derivative of x squared. Again, power rule will just be a 2x. And typically, with our implicit differentiation, we would just left that as 2x. But we took our derivative with respect to time, not with respect to x. So we have to give it a dx dt as well. All right, so just the implicit differentiation is really important you understand why the dy dt and why the dx dt exists. Because if you can do that, oh man, you're in the money now. So that's about half the problem. Once we get this, we're pretty much good to go. Because in order to solve these kinds of problems, you need you need more information, right? So the way I see it, we have 3 unknowns so far. We don't know what dy dt represents, like numerically. We don't know what the x represents numerically, and we don't know what the dx dt represents numerically. So let's give you some numeric values to play with. If x equals 1/4, and I tell you that dx dt is equal to, I don't know, 10, we can use that to figure out what dy dt would have to equal. And we're going to pick that up in our next video because we're about to run out of time. See you in a bit.